Today we are doing question and answer of the chapter force and motion. Many students think that they have correct answer of each and every question, but in examination what happens, they were expecting 50 marks in the examination, but they are getting just 25 marks because of incorrect answer they have because of different reason. That's why I want to go through question and answer. Let's have the chapter force and motion and question number 1. What is force? The heading of the chapter is force and motion. That's why I want to start with the definition of force. What is it? Force is an external agency that changes or tends to change the state of rest or uniform motion of a body in a straight line. Moreover, it can also change the direction of motion, magnitude of motion, and shape and size of the body. Force can perform two functions, that is push and pull. Actually, this definition seems to be a little heavy, but this is an agent which changes or tends to change the state of rest or motion of the body. If a body is at rest, force can change its state of rest into motion, and if a body is moving, force can stop the moving body also. Sometimes what happens, if we push the wall, then wall doesn't move even though we are applying force on the wall, and that should also come in the definition. That's why this is a little heavy definition but a little more correct. Okay, what is gravitation? The mutual force of attraction between any two bodies due to their mass. Just remember, due to their mass. And mutual force, and this is attractive force, and it produces due to the mass, is called gravitation, or we can say gravitational force. Now next question, write down the characteristic of gravitation. There are many characteristics of gravitation. I want to mention them. Gravitational force between two bodies produces due to their mass, one of the important point. And gravitational force between two bodies is mutual force. It means not only the first body attracts the second one, but the second also attracts the first one towards its center. That's why we can say this is mutual force. The mutual force between two bodies is equal in magnitude but opposite in direction. What it mean? If first one attracts second one with a force 10 Newton, then second one also attracts first one with the same force 10 Newton. It is a force which acts through the distance. No need of contact. Just for example, sun attracts earth, and that's why earth revolves around the sun. Earth attracts moon, that's why moon is revolving around the earth. This is because of the gravitation, and gravitation acts through distance. It is not affected by the presence of medium between two bodies. Whether two bodies are placed in air or they are placed in water, the gravitational force between these two bodies remains same. Okay, let's have another set. What is gravity? The force of attraction of heavenly body acting on the another body. Heavenly body may be earth, maybe moon, and the force of attraction of the heavenly body acting on another body lying on or near its surface, maybe lying on its surface or near to its surface towards the center, is called gravity of that heavenly body. Or we can say the same definition in terms of earth also. The force of attraction of the earth acting on a body lying on or near its surface towards the center is called gravity of the earth. Okay, let's have another question. Why gravity is also called gravitation? Basically, gravity and gravitation are same, but we can answer this way. The force of attraction between any two bodies of the universe. Any two bodies of the universe means maybe dust particle, maybe the stars or anything. Universe is called gravitation. But among those two bodies, if one is very huge like earth and another is comparatively very small, just like a body lying on the surface of the earth and lying on or near the surface of the bigger one, then the gravitation between these two bodies, the gravitation between them is named as gravity. So gravity is also gravitation. Write down differences between gravitation and gravity. I want to show it in table because two differences are told. The first difference may be the definition. The force of attraction of the heavenly body acting on the another body lying on or near its surface towards its center is called gravity of that heavenly body. This is the definition of gravity. And gravitation, the mutual force of attraction between any two bodies of the universe, is called gravitation. We can differentiate gravity and gravitation with its definition. Next, it is also gravitation. Which one? Gravity is also gravitation, but a special condition of gravitation. Just before this, I told you the special condition is one of them is if very huge, another is comparatively very small and lying on or near a surface, then the gravitation between these two is gravity. That's why it is also gravitation, but a special condition of gravitation. On the other side, it is true for all the bodies of the universe, whether the body is very big like stars or very tiny like dust particle, isn't it? These are the two major differences between gravity and gravitation. Let's have another question. State Newton's law of gravitation. This is very, very important. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. Now, looking at this definition, you have to be very clear that it has two parts. One, the gravitational force is directly proportional to the product of their masses. The gravitational force between two bodies depends upon product of their masses. And second part, it is inversely proportional to the square of the distance between their center. It means gravitational force depends on two factors. One is mass, another is distance. Now next, what is the meaning of gravitational force between two bodies is directly proportional to the product of their masses? Just before this in the law it is mentioned. It means when mass of the bodies is more, the gravitational force will also be high, and if the mass is less, then the gravitational force between those two masses will be less. Now next question, what is the meaning of gravitational force between two bodies is inversely proportional to the square of the distance between their center? What it mean? We can say this way, it means if the distance between two bodies is increased, then the gravitational force between them decreases, and if the distance between them is decreased, then the gravitational force between them will increase. This much writing is enough, but we can give an example also. For example, if distance between them is doubled, then the gravitational force between them will be quadrant, means 4 times less. And if the distance between them is halved, then the gravitational force between them will be 4 times more than the previous. Okay, let's have another. Do you think gravitational force between Sun and Earth is affected by planet Mercury? Give reason. No, it won't be affected by the Mercury because gravitational force between two bodies depends upon their mass and distance between them. Presence of third body doesn't make any difference on their mass and distance between them. So the gravitational force between Sun and Earth won't be affected by Mercury. Okay, now this is one of the important question. Derivation. Proof F equal to G m1 m2 by d square. For this, I want to make you more clear with the help of diagram. This is first body, its mass is m1, and this second body, its mass is m2, and they are separated by a distance d. We have to write their symbol like this. Let m1 and m2 are two bodies separated by the distance d. Now we are going to mention Newton's law of gravitation because this equation can be derived with the help of Newton's law of gravitation. So, according to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. We mentioned the Newton's law of gravitation. Now, after this, what it says that can be written mathematically like this. Gravitational force F is directly proportional to the product of these two masses m1 and m2. It means F is directly proportional to m1 m2. This is equation number 1. And second part says that it is inversely proportional to the square of the distance between their centers, which can be represented mathematically like this. We read the same symbol as inversely proportional if the quantity in right hand side is given in denominator. That's why this mathematical expression says that gravitational force between them is inversely proportional to the square of the distance between them. Okay, now if we combine equation 1 and 2, combining equation 1 and 2, what we get? This directly proportional to m1 m2 and inversely proportional to d square. Now if any quantities are proportional, then there must be a constant. We can remove this proportional sign with equal to sign, but we have to take that constant, and first constant was taken as g, and till now we are using the same symbol g, capital Z. Here capital Z is a constant called gravitational constant, and lastly we can write the equation is proved. After this, let's go to another question. What is gravitational constant, which is denoted by capital G? Be very careful about this. Acceleration due to gravity is small g, but gravitational constant is capital G. Write down with its value. I want to define this gravitational constant with the help of this diagram. Let's say we have two unit masses, 1 kg mass, 1 kg mass, unit masses, and they are separated by a unit distance 1 meter. Now the first one attracts second one attracts first one. The gravitational force between these two at this time is called gravitational constant and is denoted by capital G. We can define this way. Gravitational constant is defined as the gravitational force between two unit masses separated by a unit distance, and its value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. Let's have another question. In which condition the value of G, capital G, will be equal to gravitational force? Gravitational force is denoted by capital F. Okay, we can answer this way. According to Newton's law of gravitation, F equal to G m1 m2 by d square. Let's have clear idea with the help of diagram. Let's say these are two masses m1 and m2 and they are separated by d. The gravitational force between these two bodies is F and it is equal to G m1 m2 by d square. We know about this. As shown in the diagram, if m1 and m2 are 1 kilogram, these both are if 1 kilogram and d is 1 meter, then the same equation can be written like this. F equal to G, m1, m2 and d. All three are 1. That's why 1 multiplied by 1 divided by 1 becomes 1. It means F equal to G. This way it is proved that gravitational constant is equal to gravitational force. In which condition? When two unit masses are separated by the unit distance, then G, capital G, will be equal to gravitational force F. Okay, let's have another question. Why Newton's law of gravitation is called universal law of gravitation? We can say this way. Newton's law of gravitation is true for every substance of the universe, whether it is very huge like a star and galaxy, or it is very small like dust particle or subatomic particle. So Newton's law of gravitation is called universal law of gravitation. Let's have another. What is acceleration due to gravity? Previously we were talking about capital G. Now we are talking about small g. What is a small g? Acceleration due to gravity. Acceleration developed on a freely falling body due to the gravity of the earth is called acceleration due to gravity. Its average value is 9.8 meter per second square. When a body is dropped from height, then every second its velocity goes on increasing, and because of this reason acceleration produces, and this acceleration is called acceleration due to gravity, and its average value is 9.8 meter per second square. Now next, write down the characteristic of acceleration due to gravity. First point, we can say that it is uniform acceleration because every second the increase of velocity is same. If it is 9.8 meter per second in first second, in second second also it increases by the same 9.8 meter per second, in third second also increases by the same 9.8 meter per second. That's why it has uniform acceleration. Second, it is a vector quantity. It has not the magnitude only, it has direction also. It is directed towards the center of the earth. Now, another important part. If you are told to prove this small g is acceleration due to gravity, r means radius of the earth, and acceleration due to gravity is inversely proportional to square of the radius of the earth, we are going to prove this. If radius is more, g will be less. If radius is less, g will be more. Looking at this expression, we can understand this very clearly. Okay, how to prove? First, I want to show a diagram. This is the mass of the earth, capital M. This is the mass of the body lying on its surface, small m, and this is the radius of the earth. Now we can say that let m, capital M, mass of the earth, and small m, mass of the body lying on the surface of the earth, and r is the radius of the earth, and small g is acceleration due to gravity, and capital G gravitational constant. And according to Newton's law of gravitation, we can say that F equal to G capital M small m by r square. Instead of saying m1 m2 by d square, why I am saying so? Because instead of m1 we have taken capital M is the mass of the earth, and instead of m2 we are taking small m for the mass of small body lying on its surface. That's why m1 and m2 is not written here. In place of that, capital M and small m are written, and distance between them is the radius of the earth. That's why instead of d we are writing r. Basically this equation and F equal to G m1 m2 by d square, both are same. This is equation number 1, let's say. Now, according to Newton's second law of motion, do you remember it was taught in class 9? And Newton's second law of motion says F equal to ma, but in place of a we are writing g, because a means acceleration, g also acceleration. A is the acceleration produced by the applied force, but g is the acceleration produced by the gravity force of the earth. Both are same acceleration. That's why we can write this also. Okay, now combining these two, if F equal to this, F equal to mg, then mg is equal to this. So we can say that combining equation 1 and 2, mg equal to capital G, capital M, small m by r square. M and m cancel each other. If they are cancelled, then we'll have small g equal to capital G, capital M by r square. It means this small g depends upon capital G, capital M and r. But we know that capital G is a constant. Its value remains same. In the same way, the mass of the earth also a constant value. It won't change. That's why this small g doesn't depend upon capital G and capital M. They are constant. It only depends on capital R. So we can say like this. Here capital G, capital M are constant. That's why removing them, we can reduce this equation like this. G is inversely proportional to r square. This equal to sign is if removed, then proportional sign again comes back. G, acceleration due to gravity, is inversely proportional to square of the radius of the earth, is proved. Now let's have another question. Name the factors which affects the value of G. The first factor, radius of the earth. This is earth, its radius is different in different places. Looking at this diagram, you can understand clearly. And if you have to calculate acceleration due to gravity on the surface of the earth, you can use this equation. Yes. And second factor, height from the surface of the earth. If this is earth and we have to calculate acceleration due to gravity at this height, let's say here a body is falling at this place, then it won't be equal to small g. It has different value, and that's why I want to represent it by g dash. And g dash can be calculated by using this equation, capital G, capital M by not r square, r plus s whole square. Okay. Now third factor, depth from the surface of the earth. If this is earth and a body is at this place, then acceleration due to gravity will be small g. But when it is taken inside the earth like this, then acceleration due to gravity will be less than that of the surface of the earth. So as we go to the depth, the acceleration due to gravity decreases. Now next, axis of rotation of the earth. Earth is rotating like this, and because of its rotation, acceleration due to gravity reduces. its value will be less than the real value of acceleration. Okay, now another question. A body falls faster at pole than that of the equator. What is the reason? Now look at this is Earth and this is the radius at the pole and this is the radius at equator. What do you think? Which one is longer? Longer radius is at equator, short radius is at pole. And because of short radius at pole, value of g will be more. That is 9.83 meter per second square. Because of longer radius, value of g is less at the equator because we know that g is inversely proportional to square of the radius of the earth. And we have to understand this. We don't have to make diagram in the examination. We can write this directly. Earth is flattened at pole but bulged at equator. So polar radius is less than equatorial radius. Since small g is inversely proportional to the square of the radius of the earth, so it is more at pole than the equator. Hence a body falls faster at pole than the equator. Because of the more acceleration due to gravity, it falls faster. Let's have another question. G varies from place to place of the earth. Why? This is earth. Its radius is less at this place, it is more at this place, and it is different in different places. Look at this. And all of we know that if radius is less, then g will be more, and if radius is more, then g will be less. And so g varies from place to place of the earth. This is because g is inversely proportional to square of the radius of the earth. We don't have to make this diagram in the examination while writing answer. We can write directly, earth is flattened at the pole but bulged at the equator. So polar radius is less but equatorial radius is more, and radius is different in different places of the earth. Since g is inversely proportional to the square of the radius of the earth, and due to the variation of radius, g is different in different parts of the earth. This way we can answer this question. Okay, now I think it's enough. 20 questions are answered. We'll meet in another class with more questions. Now I want to stop this class. Thank you.